Hi everyone. This is my attempt to try to get us ahead for the exam. So I'm going to cover section 2.3, which is multiplication with fractions and the area of a triangle. So to begin, let's answer the following question. Let's consider the following question. What is 1/2 of 3/4? So let's think of it in this way. So let's say you have, a pizza that's sliced into fourths, right? Now 3/4, we remember from our previous discussion that 3/4 is basically 3 of these fourths, right? Of the whole pizza or whatever you want to call it, something round. So essentially, when I ask the question, what's 1/2 of 3/4? I'm trying to get half of this whole of the three pieces, right? So it might not be as easy right away, but if we cut this pizza into eighths, we'll begin to see a different story. Right, so let's just start this here. Okay, great. So now what I've done is I've split the whole thing into eighths without changing the 3/4, right? And I've created what's like an equivalent fraction. And now I can easily take half of it because I have 1, 2, 3, 4, 5, 6 pieces. So half of those 6 pieces, here's 1, here's 2, right? Half of 6 is 3, is equivalent to 3/8. So essentially, we've just shown in real time that half of, remember the word of means multiplication, is 3/8. Okay. So let's consider that for a second. So what happens to the numbers, the numerator and the denominator of both of these fractions when I multiply them together? So observe, how can I relate 1 and 3 so that I get 3? And, you can pause it and then answer and however you want. But essentially, we observe that the relationship is multiplication. Okay, so if you want to multiply two fractions, you basically have to multiply the numerator and the denominator. So that's in general the following rule is as so. So here's a rule. For any numbers A, B, this is an A, C, and D, where B and D, let's make them not equal to 0, okay? If you take two fractions, two rational numbers, right, and you multiply them together, the way that we do that is we multiply across the top, which is the numerator, and we multiply across the bottom, or in other words, we multiply the two denominators together, okay? Now, why do we have this rule that B and D cannot be 0? Well, that's basically because, remember, in a previous lecture, we discussed that you cannot divide by the number 0, and so we wouldn't, it's a no-no, right? Mathematical no-no. Okay, great. So let's see some examples of this. So let's do example 1. Let's multiply 3/5 times 2/7. Okay. Great. So let's do that. So we have 3/5 times 2/7, and you can use either the times mark, but I like to use the dot. And then using the rule, we just multiply across the top and multiply across the bottom, or the numerators together and the denominators together, and you'll obtain the following, which is 6/25. Okay? Well, after this, someone might ask, well, what if you have a fraction with a whole number? How do you multiply those guys together? Fine. So if you have, this is example 2. Let's say, for example, we want to multiply 3/8 times 5. That's easy enough, right? Because we recall, that didn't do what I wanted it to do. Sorry, should be focused. Why are you not focusing? Let's try this again. Sorry, guys. There we go. Okay. So let's say we want to multiply 3/8 times 5. Now recall that whole numbers are a subset of the rationals, right? We can express every whole number as a fraction by merely writing it over 1. So this problem here becomes 5/1, right? So since, note, 5 is equivalent to 5/1, they're actually the same thing, right? So now we can go ahead and use our rule, which is 3 times 5 over 8 times 1, and that gives us 15/8. Now, can we reduce this fraction at all? Remember, we were talking about prime factorization and seeing if they have common factors, and in this case, they do not, so we just leave it as is. Okay, great. So now let's have some now you tries. So now you try. And why don't you go ahead and do the following. 3/4 times 1/5. And then you would have 15/8 times 4/9. And then you could do 9/2 times 8/18. Okay? So now you try these, and I am going to assume that you're going to push the pause button and give yourself like 2 seconds or however much time you need to check your answers. So welcome back, because you've paused it, you've tried it, you've, spent some time on it, and now we're going to go over the solutions. So remember, this is a series, order of operations, parentheses first. Although we do know that multiplication is associative, so we could have done another way as well. But we go ahead and use the rule here. So we have 3 times 1 over 4 times 5, and that becomes 1/2 of 3 times 1 is 3, 4 times 5 is 20 today, and that's just simplifies to 3 times 1 again, right? And then 2 times 20, and that's just 3/40. So give yourselves a pat on the back if you got that correct. And then for the next one, we would merely do 15 times 4 over 8 times 9. Now here's something interesting. We can start to reduce these fractions at this stage, or we can go ahead and multiply them completely and then reduce at the end. I prefer to do it here because you can just factor and cancel out common factors. So let me show you that one method, and then we'll do the other method. So from this point, I'm going to go ahead and factor 15. And then 8, I'm going to notice that 4 is a factor of 8. So I'm going to rewrite that. And then I'm going to factor 9. Okay. You could also go ahead and just do prime factorization. That's fine. It works too. But in this case, I just, So then what will happen, the 4's will cancel. These 3's will cancel. Remember that 4/4 is just 1. 3/3 is just 1. And then finally, you're just left with the 5 on top and the 2 times 3 in the bottom, which is just 5/6. Okay, so that's one method. Okay. The other method would be to go ahead and you have 15 times 4 over 8 times 9. And we would go ahead and multiply that. And we would see, okay, well, let's see if we can reduce this at all. And you would have to go ahead and factor anyway by either doing prime factorization or seeing, remember, if we could find the GCD, right? The GCF, right, of top and bottom. So in this case, we observed that 60 is equal to 5 times 12, and 72 is equal to 6 times 12, and then the common factor of 12 cancels out, and you get 5/6. So there's more than one way to solve this type of problem. Okay, great. And then for this one, I'm just going to go ahead and note that 9 times 8 is 2 times 18. And then I'm going to go ahead and factor. So 9 times 2 times 4 over 2 times 9 times 2. So interestingly, these factor out. Then I get 4 over 2. But is this simplified all the way? Well, no, because 4 is equal to 2 times 2, and that's over 2. So these two cancel out, and you're left with 2 over 1. But that, of course, is just 2. Okay? So go ahead and give yourselves a pat on the back if you got that correct. And let's see. Lastly, I want to make sure that we go over area of a triangle. Sorry about that. Area of a triangle. Shh. Sorry about my dog, you guys. So remember the area of a triangle. So the proof of the area of a triangle is the fact that any triangle can be seen as half of a parallelogram, but we're not really getting into parallelograms right now. But we can definitely talk more about that later. So we take a triangle and we define the base as, basically one of the sides. We pick one of the sides. Usually the convention is that it's the side that's parallel to the ground, and we call that the base. However, it doesn't have to be so. It's just in this case. And then we define the height as being the opposing vertex. You drop a perpendicular line or an altitude, right? So basically the height is the distance from the base to its opposite vertex. Okay, so the perpendicular distance, right? So, okay, great. So that's the height. And the formula is that the area of a triangle is 1/2 base times height. Okay, so just remember base times height is also the formula for a rectangle square. A square is side squared, which is base times height. Length times width. And a parallelogram is a more general form of a it's not, rectangles are parallelograms, but parallelograms, not all parallelograms are rectangles. And so, yeah, we don't have to worry about that. So in any case, that's our formula. So let's go ahead and use it. So let's say you have, let's do an example here. You have a triangle with base 10 inches. And height 7 inches, and you want to find its area. Sorry, this is inches. Okay, so to find the area, we go ahead and use our formula, and we substitute, right? So essentially, you're just taking 1/2 of 10 times 7, okay? And because it's inches and inches, inches times inches is inches squared. Area is a two-dimensional thing, right? So 1/2 of 10 times 7. So you can do, this is 70, right? We could multiply these two or these two. We could go from left to right. Let's go from left to right, actually. Fine. Okay, so 1/2 of 10 is 5. And then we bring down the 7. And that's 35 inches squared. So remember, we have two dimensions. It's squared. Area is terms of units squared. Okay? So now you can go ahead and try the homework that I've posted online, and please enjoy. Feel free to email me with any questions you may have, okay? All right, thanks.